morning, Junior 6. How are you today? Let's start to explain our lesson today, which is called the carbon dioxide gas. Lesson 2 in Unit 3, carbon dioxide gas. You know from the previous lesson that the atmosphere consists of oxygen, nitrogen, carbon dioxide, and other gases. And oxygen represents 21, nitrogen represents 78, and carbon dioxide and water vapor and other gases represents 1. But the percentage of the carbon dioxide gas only is 0.03 from the atmospheric volume, from the volume of the atmosphere, or from the volume of the atmospheric air. So the percentage of the carbon dioxide gas is 0.03 from the volume of the atmosphere. This percentage is very small, but although the small percentage of the carbon dioxide gas in the air, but it's necessary or it's very important for the green plants. It's very important for the green plants. Why? Because the green plants take it from the air to produce their own food or to make their own food by process called photosynthesis process. So the green plants take the carbon dioxide gas from the air and then release the oxygen gas to make their own food by process called photosynthesis process. The structure of the carbon dioxide gas. Its molecule consists of one carbon atom linked with two oxygen atoms to produce CO2. So the molecule of the carbon dioxide gas consists of one carbon atom linked or combined with two oxygen atoms to produce CO2. And the carbon dioxide gas, it's a chemical compound found in the form of the gas in its natural state in the atmosphere. The sources of the carbon dioxide gas. Carbon dioxide gas is produced from number 1, the respiration of all living organisms. The carbon dioxide gas can produce from respiration of all living organisms. Because the living organisms take the oxygen gas during process called inhalation process and then release or produce the carbon dioxide gas during the exhalation process. So when you breathe in, you take the oxygen gas and then breathe out to produce the carbon dioxide gas. Number 2, the combustion of any organic materials like wood, coal, gasoline, tobacco, or candle, or oil. All of these are organic materials. So when you burn any organic materials, it will produce the carbon dioxide gas. And number 3, the combustion of fuel in factories and means of transportation. The fumes that come from the factories and means of transportations like this and this contains the carbon dioxide gas. So the burning of fuel in factories and means of transportation can produce the carbon dioxide gas. Now, how to detect the carbon dioxide gas in the exhaled air? How to test or make sure that the exhaled air contains carbon dioxide gas? To make sure or to test or to detect the carbon dioxide gas In the exhaled air, pour some lime water in a jar, clear lime water in a jar, then blow in this clear lime water for 2 minutes using a straw. You can see the clear lime water becomes milky or turns into milky or turbid due to the formation of calcium carbonate, due to the formation of white matter, which is called the calcium carbonate. So, this means that the exhaled air contains carbon dioxide gas, because the carbon dioxide gas reacts with the lime water to produce calcium carbonate, which is white matter. So, to detect or to test the carbon dioxide gas in the exhaled air, we use the lime water, because the lime water will turn into milky due to the formation of calcium carbonate.
Assalamu alaikum. Our activity today, carbon dioxide gas makes clear lime water turbid. We have here 2 beakers, each of them contains clear lime water and a straw. We are going to blow air inside clear lime water. Clear lime water becomes turbid. We can notice the difference between the 2 beakers. This beaker becomes turbid due to the formation of calcium carbonate insoluble in water. This beaker contains clear lime water.
The question now give reason. The lime water is used to detect the presence of the carbon dioxide gas. Why? Because the lime water turns into milky or turbid due to the formation of the calcium carbonate. So the lime water turns into milky or turbid. Now, we will talk about the percentage of the carbon dioxide gas. It represents 0.03 of the volume of the atmosphere. But this percentage can increase. Why? Or due to, because the removal of forests, if you remove the green plants or remove the forests, so you can increase the percentage of the carbon dioxide gas, because the green plants take the carbon dioxide gas, and if you remove the green plants, so it doesn't take the carbon dioxide gas. So the percentage of the carbon dioxide gas will increase. And number 2, the burning massive amount of fuel in factories and means of transportation. When you burn great amount of fuel in factories or means of transportation, so you can increase the percentage of the carbon dioxide gas. Now we will talk about the preparation of the carbon dioxide gas in the laboratory. How can we prepare the carbon dioxide gas in the laboratory? by the reaction between dilute hydrochloric acid. By the reaction between dilute hydrochloric acid and calcium carbonate. So the carbon dioxide gas is prepared in the laboratory by the reaction between dilute hydrochloric acid and calcium carbonate. So we can prepare the carbon dioxide gas by adding calcium carbonate, then drop dilute hydrochloric acid. So the carbon dioxide gas is prepared. You can observe here the effervescence of the carbon dioxide gas. In this jar, the carbon dioxide gas is collected. So when we put a lighted paper in the jar, in the carbon dioxide gas, it will extinguish. So the carbon dioxide gas used in extinguishing fire, like this. So you can prepare the carbon dioxide gas in the laboratory by reaction between dilute hydrochloric acid and calcium carbonate. And the carbon dioxide gas is collected by upward displacement of air. You observe here, it collected by upward displacement of air. Why? Because the carbon dioxide gas is heavier than the air. Because the carbon dioxide gas is heavier than the air. So it collected by upward displacement of air. Upward displacement of air. And the carbon dioxide gas is not collected by the displacement of water, because the carbon dioxide gas can dissolve easily in the water. It easily dissolves in the water, so it doesn't collected by the displacement of water. It collected by upward displacement of air. Upward displacement of air. You have to know that you can prepare the carbon dioxide gas also by adding lemon juice or vinegar to the sodium bicarbonate, or the baking soda. So you can prepare the carbon dioxide gas by lemon juice or vinegar, adding them to the sodium bicarbonate or the baking soda. Now, let's know the properties of the carbon dioxide gas. Number one, the carbon dioxide gas is colorless and odorless because it has no color and has no smell. Number two, the carbon dioxide gas is heavier than the air, like the oxygen gas. It's heavier than the air, so it collected by displacing the air upward and replacing it. Displacing the air upward, or this upward displacement of air, and replacing it. It takes the place of the air. And the carbon dioxide gas is easily dissolves in water. It easily dissolves in water, so it doesn't collected by displacement of water because it easily dissolves in water. Number four, the carbon dioxide gas doesn't burn and doesn't help in burning. It doesn't burn and doesn't help in burning. If you put a lighted candle, then turn a cylinder filled with the carbon dioxide gas upside this lighted candle, you will see that the lighted candle will extinguish. Why? Because the carbon dioxide gas doesn't burn and doesn't help in burning, so it's used in extinguishing fire. Number five, the carbon dioxide gas can react with the lighted magnesium ribbon to form the magnesium oxide, which is a white powder, and carbon, which is the black substance that deposit in the walls of the cylinders. If you insert a lighted magnesium ribbon in a cylinder filled with carbon dioxide gas, you will see that the magnesium ribbon keeps burning for a short time, then extinguishing, forming a white powder and a black substance. The white powder is a magnesium oxide, but the black powder is a carbon. So it reacts with the lighted magnesium to form a white powder, which is the magnesium oxide, and the black substance, which is a carbon. Okay, so what are the properties of the carbon dioxide gas? Number one is colorless and odorless. Number two, heavier than the air. So we collect the carbon dioxide gas by upward displacement of air. Number three, it easily dissolves in water, so it doesn't collected by displacement of water. Number four, it doesn't burn and doesn't help in burning, so it's used in extinguishing fire. Number five, it reacts with the lighted magnesium to form white powder and black substance. The white powder is magnesium oxide and the black substance is a carbon. Let's solve this evaluation. Complete the following. Number one, we can get the carbon dioxide gas by adding dilute what to what? Yes, by adding the dilute hydrochloric acid to the calcium carbonate. By adding the dilute hydrochloric acid to the calcium carbonate. Number 2, the carbon dioxide gas reacts with lighted magnesium forming, yes, magnesium oxide and carbon. Number 3, what gas doesn't burn and doesn't help in burning? Yes, it's a carbon dioxide gas. Number 4, the carbon dioxide gas is collected by upward displacement of air. Number 5, when adding lemon juice to sodium bicarbonate, what gas is produced? Yes, the carbon dioxide gas. Now, let's know the disadvantage of the carbon dioxide gas. Increasing the percentage of the carbon dioxide gas in the air may cause it, number 1, the suffocation of the living organisms. Suffocations of the living organisms. And suffocations means it's the difficulties in the breathing. So the living organisms can suffer from suffocation or difficulty in breathing. And number 2, the increasing the temperature of the Earth's atmosphere, which is called the global warming. So the disadvantage of the carbon dioxide gas, by increasing the percentage of the carbon dioxide gas in the air, so it will cause suffocation of the living organisms and increasing the temperature of the Earth's atmosphere, which is called the global warming. So the global warming is increasing in the temperature of the Earth's atmosphere. Thank you, Junior 6. Goodbye.